Have you ever used a tool that should just be great, but it just doesn't suck? What? Well, that's what sparked the idea for today's project. I've got this rigid sander, and despite not being a rigid tool fan, I have to admit, this thing's actually great. But when using it as is, it basically turns my shop into a Dune sequel. Just endless dust storms, bad air quality, no spice, just wood dust. So today, I'm going to fix that. And when I'm done, this tool's gonna totally suck. And it's gonna suck in the best way possible. And if you don't own the rigid, I've got designs to accommodate the other 5 manufacturers, so I've got you covered. So to fix this, I first need to look at why this thing's so bad at dust collection. Well, it's obvious. The dust port's tiny, it's stuck in a terrible location, and it does almost nothing at capturing the dust being flung off the belt at 215 RPM. So instead of working with this bad design, I'm gonna work around it. And I feel by modifying this in a complex way, will make it harder for others to achieve this level of excellence. So I've put together 3 objectives that I want to incorporate into my design to make it easier for others to install and use this with their machines at home. Number 1, I want this to be bolt-on, easy off, no heavy modifications. Number 2, I want this to accommodate 4-inch dust collection hose to maximize CFM pull at the tool and helping to ensure maximum fine dust collection. And number 3, I just want the damn thing to work. So now that we know the why behind why this doesn't suck, we need to work on making this thing actually suck. So this project video is a little different for me. Most of the work is done in Fusion and a lot of time was spent 3D printing the parts, and quite frankly, I felt making the video heavily based on those 2 things would make for boring content. So instead, I'm going to show a couple tricks for the newbies and some key milestones that got me to my final product. It's easy to start off by making this more complex than it needs to be, so hold off on getting out every sophisticated measuring device you own and the expectation of taking hundreds of unnecessary measurements, because those days are over. Alright, so all we need is 2 basic measurements and 1 picture. So check this out. I'll grab a width measurement, a depth measurement, and snap an overhead photo of the tabletop. Pretty easy. With those, I can jump into Fusion, sketch a rectangle that matches those dimensions, drop my photo in, and stretch it to fit those borders. This will give me a damn near perfectly scaled image to trace the important attributes of the sander's tabletop that are key for my duster to properly fit. Most notably, the leading radius of the belt assembly, the mounting hole, and this slot. More on that later. And man, does it feel great to have the hardest part behind me. Everything else was up to my imagination. What could go wrong? Now, it came by no surprise that the easy part was going to be getting this to fit and mount to my sander properly. Making a small test print to confirm the fitment before printing the dust hood in full not only saves time, but also filament. Where I tend to struggle is with the balance of design appearance and ease of printability. Making a design look good is only half the battle. I've learned that keeping printability in mind while designing has helped make up for my lack of skill in 3D printing, especially with surface quality and overhangs.
Buzz your girlfriend. Woof.
A common technique I like to use with complex items is printing them in multiple pieces that can be assembled later on. And that's what I initially did, but I couldn't get past how ugly this glue seam was. And although this has no negative effect on the hood's performance, it just reeked of amateur. Looking this over in complete disgust made me realize how big of a bonehead I was being. There was no reason why I couldn't print this in one piece and eliminate that nasty glue line altogether. So that's exactly what I did. So with the final design in hand, I needed a way to fasten this to my sander, so I designed a quick ergonomical thumb knob to use with a 1/4-20 bolt, which makes for a smooth install and a quick removal. So before testing this hood out and giving it the dust it craves, I first need to clean up this hideous duct run and give the Sidewinder a proper setup. Now, I've talked about this incomplete section of my dust collection in a few videos, so I decided to clean it up with this true 6-inch to dual 4-inch transition. But I needed to accept one 4-inch flex hose that goes to my bandsaw and one 4-inch PVC duct to support this sander. So once again, I designed my own solution to fix this problem. Now my inner nerd wants to see what the CFM pull at the tool is after this upgrade. This has become a common practice, or more like an obsession in my shop since upgrading my dust collection. And out of all of my habits, this is probably the healthiest. To calculate the CFM, I need to know the airspeed. So I'll be using an anemometer to read the air velocity at the tool in feet per minute. But before I can use this, I need to remove this. Some basic math shows me that I'm hitting around the 665 CFM mark, which is pretty damn good. But to show how much of an upgrade this is, let's look at the factory dust port with a common rigid shop vac with a 2-inch hose. Now to be clear, I can't fully fit my anemometer into the belt assembly well, so to give this an even better fighting chance, I'm going to base the reads directly off the 2-inch hose dimensions. This will only overinflate the reads to look better than what they actually are at the machine itself, so keep that in mind. And with no surprise, the factory setup falls short, only allowing 120 CFM, best case scenario, at the tool. Now it's safe to say, this is a huge upgrade over the factory setup. Easy install, 6 times better dust collection than before, and plenty of clearance to accommodate oversized stock. But it does have one minor drawback, and I'm sure some of you have already jumped into the comment section to let me know. Without a doubt, the elephant in the room is that this hood will limit the ability to sand inside curves. And this has been on my radar since inception, but I can honestly say 95% of the tasks I use this sander for don't require sanding inside curves. But keeping the other 5% in mind is why designing this to be installed and removed in the matter of seconds was high on my list of priorities. The use of a single thumb knob for install and removal will come in clutch for those one-off times that require inside curve sanding. And after many asks, I've expanded the Sidewinder family to fit 5 more common manufacturers. So if you're wanting to make your sander totally suck, I have these for sale over on the Brewbuilds Etsy store. All hardware is included, and I've also included free shipping. I'll have the link for the Sidewinder hoods in the video description. Alright, so these are definitely fun to design and watch come to life. And it's just one more step in keeping the air quality healthy in the workshop. So as always, I hope you enjoyed. Thanks for watching, and I'll catch you guys on the next one.